In questions 12 through 15, we're going to write an equation of variation, and then we're going to use the equation to find a specific value. So in 12, d varies directly as the square root of t. So let's write that with the variable, or the constant k. V varies directly, that means equals k times the square root of t. And d is 36 whenever t is 9. So that means that 36 is equal to 3 times k, which means that k must be 12. So our equation of variation is d is equal to 12 times the square root of t. So that's coming from the original variation equation that we wrote with the specified value of the variation constant k. So that's the first answer to our question. And then the question asks to find d when t is equal to 100. So when t is equal to 100, we can replace the t with 100. And then d is equal to 12 times the square root of 100, which is 10. So that would be 120. And that's the answer to the question. In number 3, y varies inversely as x plus 5. Translating that equation, y equals k divided by x plus 5. And we know that y is equal to 8 whenever x is equal to 1. So 8 and 1 can be replaced, can replace the y and the x. So that gives us 8 is equal to k divided by 6. Multiplying both sides of the equation by 6, we get k is equal to 48. So the equation of variation is y is equal to 48 divided by x plus 5. That's the variation equation. And then we're going to use that equation to find the specified value. We're asked to find y when x is 7. So y is equal to 48 divided by 7 plus 5. So just replace the x with 7, and that's 48 divided by 12, which is 4. In number 14, f varies jointly as a and b cubed. Joint variation means that f varies directly with both quantities, so f is equal to k times a times b cubed. The value of f is 60 whenever a is 5 and b is 2. So that gives us 60 is equal to k times, and 2 cubed is 8 times 5 is 40. So dividing both sides by 40, we get a k value of 3/2 when we reduce the fraction. So the equation of variation is y is equal to 3/2 times a times b cubed. Now we're going to use that equation to find the requested value. It said find the value of a whenever f is 32 and b is equal to 4. Now I just realized I mistyped that equation right there. It should be f is equal to 3/2 times a times b cubed. So replacing the f with 32 and replacing the b with 4, we get 32 is equal to 3/2 times 64 times a, since the multiplication can be done in any order. So 32 is equal to, and 3/2 times 64 is 96. So 96 times a, and we'll divide by 96, and that gives us an a value of 1/3. In 15, y varies directly as c and inversely as the square of d. So y equals k times c, because that's a direct variation, divided by the square of d. That's d to the second power. And y is 32 whenever c is 4 and d is 3. And so that's going to give us an equation. 32 is equal to 4 times k divided by 9. So I'm going to, I guess I could multiply by 9 first, but if I want to do this a little bit more cleverly, what I can do is I can multiply by 1/4 first. So 1/4 times 32 is equal to 4k over 9 times 1/4. And that's going to give me 8 is equal to k over 9. Now I can multiply both sides by 9, and k is equal to 72. So my equation of variation is y is equal to 72 times c divided by d squared. We're asked to find the value of y when c is equal to 2 and d is 4. So I can replace c with 2 and d with 4, and that's going to give us 144 divided by 16, which is equal to 9. In 16 through 25 we have word problems, but they're going to suggest an equation of variation, and we're going to include units in the answers when appropriate. In number 16 we talk about planet Q. And on planet Q, the time it takes for an object to fall varies directly as the square root of the distance it falls. So, if I let t equal time, then time t varies directly, that equals k times the square root of the distance that it falls, so I'll call that letter D. An object that is dropped from a height of 4 feet, that would be the distance that it falls, so I'll replace d with 4. Takes 6 seconds, that would be the time, so I'll replace t with 6 to hit the ground. That's going to allow us to solve for the constant k, so the square root of 4 is 2, and dividing both sides by 2, we get k is equal to 3. So our equation of variation now is t is equal to 3 times the square root of d. Once we have that equation of variation, the question asks how long it will take for an object to be dropped from 25 feet to hit the ground. How long will it take means we are looking for time, and 25 feet is the distance to the ground. And so replacing d with 25, we get 3 times 5, so t is equal to 15, and the times were measured in seconds. In number 17, the time required to harvest a crop varies inversely as the number of people on the job. If it takes 8 hours for 10 people to do the job, how long will it take for 32 people to do the job? So we'll write an equation of variation. So time varies inversely, that means equals k divided by the number of people on the job. So the time it takes for 10 people, that would be p equals 10, to do the job is 8 hours, so that would be t is equal to 8. That's going to give us a k value of 80 when we solve. So that means the equation of variation is t is equal to 80 divided by p. The question is now, how long will it take for 32 people to do the job? So t is equal to 80 divided by 32, because p is equal to 32, the number of people on the job. Let's reduce that fraction. We can reduce it by a factor of 4 at least. So let's reduce by 4 and see what happens. 4 into 80 goes 20 times. 4 into 32 goes 8 times. We can reduce even further by another factor of 4, and that will give us 5 divided by 2, which is going to be 2.5. So that would be 2 hours and 30 minutes. In number 18, a Martian's IQ varies directly with the square of the number of tentacles that it has. A Martian with 5 tentacles has an IQ of 75. We want to find the IQ of a Martian with 8 tentacles. So let's let IQ be the letter I. So I varies directly, equals k times the square of the number of tentacles. So let's let that equal t squared. the number of tentacles squared. And so a Martian with a Martian has 5 tentacles, so that would be T is equal to 5, has an IQ of 75. So that gives us 75 is equal to 25 times K, dividing by 25, K is 3. So that means our equation of variation is I is equal to 3 times T squared. Now we want to find the IQ of a Martian with 8 tentacles. So we're looking for I, but we know the number of tentacles is 8. So that would be an IQ of 3 times 8 squared, or 3 times 64, which would be an IQ of 192. In number 19, by Ohm's law, the current flowing in a wire varies inversely as the resistance of the wire. So let's let C equal current, and that varies inversely, so that's equal to K divided by the resistance, let's call that R, of the wire. If the current is 5 amperes, when the resistance is 24 ohms, that gives us an equation that will allow us to solve for the constant of variation K. So multiplying both sides by 24, we get K is equal to 120. That means that our equation of variation is C equals 120 divided by R. So the question is, for what resistance will the current be 8 amperes? So 8 is the current, and R is unknown. I'm going to multiply both sides by R, and we get 8R is equal to 120. Now dividing by 8, that will give us a resistance of 15 ohms. In baseball, a pitcher's earned run average varies directly as the number of earned runs allowed, and inversely as the number of innings pitched. So let's write that equation of variation. The earned run average, let's just call that A, varies directly, so that equals K times the number of earned runs, so let's call that R for runs, and inversely as, so that means divided by the number of innings pitched, so let's call that I. So if a pitcher has an earned run average of 3.6, so that means A is equal to 3.6, after pitching 95 innings, so that means I is 95, and allowing 38 earned runs, so that means R is equal to 38, what is the earned run average of a pitcher who gave up 70 earned runs in 300 innings? All right, so we are going to multiply both sides by 95, and that will give us 342. This is probably one where we want to use a calculator. Everything else out here I think we can do without easily. So now we're going to divide by 38, and when we divide by 38, we're going to get a K value of 9. So our equation of variation is A equals 9R divided by I. And so now we can use that equation to find the earned run average. So we're going to find A of a pitcher who gave up 70 earned runs. So 70 is the value of R in 300 innings. So 300 is the value of I. Now doing our arithmetic, that gives us 630 divided by 300, which is an earned run average of 2.1. In 21, the intensity of a light varies inversely with the square of the distance between the light and the object illuminated. So intensity varies inversely with the square of the distance. So I equals K divided by, for inverse variation, the square of the distance, so that's d squared. And we know that a light that is a light meter that's 2 feet from a light, so that would be the distance, registers an intensity of 25 lux. So that's 25 is the value of I. So 25 is equal to K divided by 4 multiplying by 4, that gives us an of k of 100. So I is equal to 100 divided by d squared. And we are looking for the intensity that it would register 5 feet from the light. So I is equal to 100 divided by the distance, which is now 5. So that would be I equals 100 divided by 25, and that would give us 4, and the units on the intensity are lux, or LUX. In 22, the kinetic energy of an object varies jointly with the mass of the object and the square of its velocity. So, energy varies jointly with mass and the square of the velocity. So let's write an equation from that. Energy, E, varies jointly equals k times the mass and times the square of the velocity. The kinetic energy of a ball with a mass of 3 kilograms, so that would be the value of m, traveling 6 meters per second, that would be the value of v. So we're going to replace the v with 6. Has an energy of 54 joules. So 54 is the value of E. So 54 is equal to k times, and that would be 3 times 36, which is 108. So 108 times k. Dividing both sides by 108, k is equal to a half. So that makes the equation of variation here, E is equal to 1/2 mv squared. And we are trying to find the mass of a ball that generates 250 joules of energy. So 250 is the value of E, but we're looking for mass while traveling at 10 meters per second. So 10 is the value of V, and that's going to get squared. So 250 equals 10 squared is 100 times a half is 50, so 50 times m, and then dividing both sides by 50, m is equal to 5. Our masses are measured in kilograms. In 23, the number of hours that it takes to assemble machines varies directly as the number of machines and inversely as the number of workers. So let's let H equal number of hours that it takes to assemble machines varies directly equals K times the number of machines, let's let that be M, and inversely is the number of workers, so divided by W for the number of workers. We know that if there are 4 workers, so that's the value of W, that they can assemble 12 machines, so that's the number of machines. We don't know the value of K, and 4 is the number of hours. That'll allow us to find the value of K, so I'm going to multiply both sides by 4. We get 12 times K is equal to 16, and then dividing by 12, that gives us the value of K. Let's reduce that by a factor of 4. That's 4/3. So our equation of variation is H is equal to 4/3 times M divided by W. It's a complex fraction, but I think we'll figure out what to do with this. So we are looking for the number of workers. So we're looking for W, that's not given, and we know that 4/3 is the value of K, and we know the number of machines that we're looking to assemble is 36 machines, and we're looking to do this in 8 hours. So 8 is the value of H. We can simplify what's on the top in the fraction. 4/3 times 36 is 4 times 12, or 48. So 48 divided by W is equal to 8. Multiply both sides by W. 8 times W is equal to 48, and W is equal to 6. So that's 6 workers. In 24, the maximum weight that a rectangular beam can support. So weight varies jointly as the width and the square of the height, and also inversely as the length. So weight varies jointly as equals k times the width and the square of the height, and inversely as the length. If a beam is 1/2 foot wide, so actually it occurs to me now that I have two W's in here, so I'm going to change one of them. Let's change that maximum weight to an M for maximum. So a beam that is 1/2 foot wide, so that would be the value of W. 1/3 foot high, so that would be the value of H, so we have a 1/3 squared there. And 10 feet long, so that would be the value of L, can support 12 tons. So that's the maximum weight in tons. All right, I'm going to multiply both sides by 10. That's going to give me 120 is equal to K times, and 1/3 squared is 1/9 times 1/2 is 1/18. What I can do from here is I can multiply both sides by 18. And that will give us a value of 2160, which is equal to K, the constant of variation. So our equation is M is equal to 2160 WH squared divided by L. So we are looking for how much weight, that's the value of M, that a beam of the same material support if it's 2/3 of a foot wide. So that would mean that we're going to replace the W value with 2/3, and 1/2 foot high, so we'll replace H with 1/2, and a length of 16 feet. So again, we may want to use the calculator here for some of these computations. 1/2 squared is 1/4 times 2/3 is 2/12 or 1/6. And then that's divided by 16. So 2160 times 1/6 is the same thing as 2160 divided by 6, and that's going to give us 360 divided by 16, which is 22.5 tons. All right, we'll try to keep the numbers nicer on a quiz or a test. In 25, the last question, the electrical resistance of a wire, so let's call resistance R, varies directly as equals K times its length times L, and inversely as the square of its diameter, so that's divided by the square of D. All right, the resistance of 640 feet of copper wire, that sounds like a length, with a 1/4 inch in diameter, so that's a 1/4 squared in the denominator, has a resistance of 16 ohms. All right, so we have 16 equals 640K, and we're dividing by 1/4 squared, which is divided by 1/16. The easiest way that we can approach this is to multiply both sides by 1/16. That'll undo the division by 1/16. That'll give us a 1 is equal to 640K, and K is 1 over 640. At this point, we can replace the value of K with 1 over 640. And then we are finding the resistance of 320 feet. So that would be the value of L, and a 1/2 inch in diameter. So half gets squared. All right, let's do the computations. 1 over 640 times 320 is a 1/2. So a 1/2 divided by a 1/2 squared. So that's going to be equal to a 1/2 divided by a 1/4, which is a 1/2 times the reciprocal, and that's going to give us a result of 2 and that's going to be measured in ohms.